All right, today we're going to learn about inductive and algebraic reasoning, so just some rules for some of the logic statements and some of the proofs that are going to be coming up later in the chapter. So the first thing we want to talk about is inductive reasoning. And inductive reasoning is simply reasoning based on patterns you observe. So you look for a pattern and then you make a conjecture about what's going to come next. So it might be like a sequence of numbers or a sequence of shapes or whatever it might be. And you're just kind of trying to find a pattern within and then just making a guess what comes next in the sequence. So this word here, conjecture, what we mean is a guess based on observations. So we're looking for this pattern, we see the pattern, and then we apply that pattern to guess what's going to come next. So those are the things that we're going to be working on first in this section. So for instance, you might get a couple of sequences like you see here. So the first one is 12, 17, 22, 27, 32. So as we look at those numbers, we look for a pattern. And so what you might notice is that each time we go to the next term, we're simply adding 5. So every time we go to the next term, we add 5. So if we add 5 every time, and I want to find the next 3 terms in the sequence, I'm going to add 5 to 32. So my next term would be 37. Add 5 again would be 42. Add 5 again would be 47. So those would be the next 3 terms in the sequence based off the pattern we observe. In the second example, we go 1, 4, 9, 16, 25. So this one actually has a couple different patterns you could apply. A lot of times what people look at is, okay, if I go from this term to this term, I add 3. If I go from this term to this term, I add 5. If I go from this term to this term, I add 7. When I go from this term to this term, I add 9. So as I look at the addition, I'm going up by 2 every time. So 3, then 5, then 7, then 9. If I continue that pattern, my next term should add 11, and so I get 36. And then I should add 13, so I get 49. And then I add 15, which would give me 64. So that's one possible way to get the pattern, or the next 3 terms. Now, others of you might know or recognize that these numbers are actually special numbers. They're called perfect squares. So that first term, 1, is just 1 squared. 4 is 2 squared. 9 is 3 squared. And so if we continue that pattern, we have 4 squared, 5 squared, and then our next patterns would be 6 squared, 7 squared, and 8 squared, which would be 36, 49, and 64. So there might be more than one pattern to a given sequence. You just have to figure out the pattern you know and then apply that pattern to get those next terms. Next thing, properties of equality. So this kind of leads us into our algebraic reasoning. So on these properties, these are all properties that you guys have seen before. There might be a couple of new ones here in the reflexive, symmetric, and transitive, but everything else is something you have done in your algebra classes in the past. So for instance, the addition property. When we look at the addition property, so we're letting A, B, and C just be numbers. So we're just letting them be any number that we can think of. If I have an equation, A equals B, I can add the same number to both sides and maintain my equality, meaning if A was equal to B, then if I add C to A and I add C to B, my left and right sides are still identical. Where you would have seen this before is if you're solving the equation x minus 4 equals 10, for instance. So if I have x minus 4 equals 10, so I have this left side equal to the right side, I know I can add 4 to both sides and my equation still holds. So the 4's cancel, I get x is equal to 14, and I get my solution. But I added the same number to both sides, and the left and right side stayed equal. So that's all that addition property is saying. Same thing then with the subtraction property. So the rest of these kind of follow pretty closely to that one there. So subtraction, I can subtract the same number from both sides. If I had the equation x plus 5 equals 20, I can subtract 5 from both sides, and my equation still holds. So then x would equal 15. Same thing with division, same thing with multiplication. So as you're looking at these different properties here, these are ones that you guys have already used to simply solve equations. I can add a number to both sides, I can subtract a number from both sides, I can multiply a number by both sides. So it's just saying that any of those properties of equality or any of those operations that you've learned in previous classes will hold in these algebraic equations. Now the new ones, the reflexive property says that something is equal to itself. So that seems kind of like a trivial statement, but it is an important one when we get into our proofs in the later sections here in the chapter. So anything is equal to itself. Anything is the same as itself. And that should be pretty straightforward, but it's something that we're going to be using a couple of times throughout the next chapter. The symmetric property, if I have an equation, A equals B, I can flip-flop that equation and the left and right sides will still be equal. So if I have an equation like 10 is equal to x plus 4, I can flip that equation and say x plus 4 equals 10. So that symmetric property is just saying I can flip-flop an equation and maintain equality. The most common part or use for this one, though, is like if I'm solving an equation in a proof and I come up with 4 equals x, well, I don't ever want x on the right side, so the symmetric property says, okay, I can flip-flop this and let x equal 4. So anytime you see something being flip-flopped, that's that symmetric property. The transitive property is kind of like a 1, 2, 3 step. So if A is equal to B, and then B is equal to C, A must be equal to C. So it's just saying if 1 leads to 2, 2 leads to 3, then I can go straight from 1 to 3 directly. Another thing that we kind of talk about with this one, we call it kind of the middleman property. And that's because if you notice here, like B is in both statements. So I have this middleman B. So A is related to B, C is related to B, so I can get rid of the middleman, and A must be directly related to C. So that's that transitive property, like one thing leads to the next, leads to the next. So it's kind of like following a trail. The substitution property, if A equals B, then B can replace A in any expression. So this is, again, something that you have seen in the past. You might say that the measure of angle ABC is 3x plus 2, and you might know from a previous step that x is equal to 4. Well, by substitution, I can place that 4 in for x. So I can take 3 times 4 plus 2. So substitution is just allowing us to take one thing and replace it with another. Or you might see an equation where, well, we'll see some examples in a little bit here. So you'll see what that substitution property looks like. The last one's distributive, and this is one you've definitely seen before. When you have a number outside of parentheses, so this A times B plus C, I can distribute that A to both terms. So A times B plus A times C. It works for both plus and minus, so A times B minus A times C. So the distributive property is just kind of taking that number and multiplying it through to everything in the parentheses. So these are all properties that you'll need to know. So we're going to practice with these by looking at some examples. So one of the types of problems you're going to be expected to know how to do is when you look at a statement, what happened from statement 1 to statement 2, what property was applied. So if we're looking here, we start with AB equals CD. And in the second statement, we change from AB equals CD to AB plus 2 equals CD plus 2. So one of the things you have to look at with these types of problems is what changed. What happened from statement 1 to statement 2? Well, I still have my AB and CD, but now I put a plus 2 on both sides. Well, so that tells me I'm using my addition property. I added to both sides, so that's my addition property. That would be my answer. If I look at the second example, we started with 3x equals 24. And then when we went from step 1 to step 2, now we have x is equal to 8. So we have to think to ourselves, well, what changed? So what happened from that first step to the second step? And so what happened was they divided both sides by 3. So they didn't show the division, but they divided the 3x by 3 and got x. They divided 24 by 3 and got 8. So there's your division property of equality. So you're just looking at the statements and figuring out what changed. From step 1 to step 2, what did we do? Same thing on these next examples. So if we look at this example here, measure of angle A equals measure of angle B, and then notice they flip-flopped the two statements. So then they just moved angle B to the left and angle A to the right. So when we flip-flop like that, anytime we see that switch, that's our symmetric property. So that's one of our kind of newer ones. That's one you want to kind of make sure you understand. When we flip-flop the statement, we're using symmetric. In our next example, we have JK plus KL is equal to GH plus KL. And then they go from that to JK equals GH. Now, if I look at what changed, from step 1 to step 2, I got rid of these KLs. Now, since I was adding the KLs initially, the only way to get rid of them would be to do the opposite operation. So if I was adding KL, I then need to subtract KL from both sides. So this would be a subtraction property. One thing to note here, if you're going to be abbreviating, so if you're not going to write the whole term out, subtraction or division or whatever, and you're abbreviating, make sure with subtraction, you have to have the T on that abbreviation. You can't just write SUB because there's also a substitution property, and so I don't know which one you're talking about unless you put the T on the subtraction. So make sure you're very careful with that. Last couple examples here. So if we look at that first one there, we see the 3 times the quantity x plus 3 equals 56. And then in the very next statement, we go to 3x plus 9. So if we think about what happened here, it looks like what they did was they distributed the 3 to both terms. So 3 times x and 3 times 3. So this would be our distributive property of equality. When we look at the next one, x equals y and y equals 2. So x must equal 2. Now this one can be actually one of two things. So if I look here, I have x equals y and then y equals 2. Notice I have y in both statements. So x led to y, y led to 2, so then x goes straight to 2. This would be our transitive property. 1 led to 2, 2 led to 3, and so on. So that's our transitive property, that middleman. We can get rid of the y's that are in common, and we can go straight to x equals 2. Now the other thing we could look at here is the fact that I had this equation x equals y to start with. And then the very next thing they tell me is that y is equal to 2. So right here, what they're telling me is I can take 2 and replace it anywhere I see a y. So over here in this original equation, x equals y, I could replace y with 2. And so another option here would be the substitution property. So this is what a substitution would look like. I take one thing and replace it with another. Another thing here, just like with subtraction, if you're going to abbreviate, make sure you put the S at the end there so I know you're talking about substitution versus subtraction. So the abbreviations, make sure you're careful with those. With that, you should be able to complete the assignment for today, which would be the worksheet. So you can either get the worksheet in class, or if you're at home, you can print it off or work it on another sheet of paper. As you work through it, if you have questions, make sure you ask, either in class, email, whatever, and then make sure when the answer key comes out, you check that as well to make sure everything looks good before you turn it in.